Okay, so the very first question always is to say and spell your name for Steve so that he can, when he does the little thing at the bottom there, that he does it right, and also your title.
Okay. John Verboncor, John space Verbonceur. I'm the Associate Dean for Research in the College of Engineering. My faculty appointment is joint between Electrical and Computer Engineering and a new department called Computational Mathematics, Science and Engineering. Don't know if you need that last part, but in case you do, you have it.
Okay. Yeah. Okay. So tell us briefly what Mobility Studio is.
So Mobility Studio is our MSU branded effort to look at the mobility space as a system. And so that includes autonomous vehicles, it includes also smart infrastructure, and it includes software to tie those together through modeling and optimization and management. And by mobility in this context, we really mean vehicles, automotive trucks and so forth, as well as lighter motorized vehicles, pedestrians, and cyclists. So really the whole ecosystem of mobility.
Okay. Talk a little bit about the smart infrastructure part of this.
Okay. So smart infrastructure in the MSU framework really deals with things like sensors. You may have seen in the news recently, we had a faculty who mounted sensors on the Mackinac Bridge, and those sensors are aimed at looking at vibrational states on the bridge. Those sensors are all powered by vibrations themselves, and they network. They don't network to a base station, they network among each other, so they're short-range networking, low-power type devices. We envision the same sort of sensors built into roadways, for example, powering them by the vibration of passing vehicles, and having, for example, high-gain antennas to direct signals at oncoming traffic to signal the edge of a roadway when it's visually obscured, for example, by snow, ice, sleet, sand, or leaves.
Okay, let's try and say that same thing a little bit more brief.
Okay.
About the role of smart infrastructure and sensor technology.
Okay. So MSU has a lot of interest in smart infrastructure from the perspective of adding sensors to various components in infrastructure. That may include bridges, it may include pavements. For example, signaling the edge of the pavement using smart sensors. It may mean, for example, smart traffic signals that telegraph oncoming traffic, visually recognize the type of vehicle and use that to estimate its stopping distance and understand how quickly they can turn the lights, looking at passing pedestrians and trying to build phase packets out of pedestrians and out of vehicles so that one could have each of those stop less frequently as they transit through a particular area.
Okay.
Still long, but I said it.
Still long, but not terribly. In layman's terms, what's the outcome of that?
So in terms of the outcome, what we're really aiming at for societal outcome is optimization of urban environments from the perspective of efficiency, but also from the perspective of safety and security. And so if we think of an urban environment, we have a number of optimizations that might really matter. For example, emissions of pollution in that environment, which is not exactly the same optimization as fuel efficiency, which is not exactly the same optimization as time to destination. So a city manager using this mobility management software might be able to optimize among each of those as the day's needs require. So for example, if you're in a city in a valley in California, you may be hitting EPA standards on emissions and you may be getting fines for the day. And if you were able to reduce those emissions even by a few percent, you could save real money up front, and then you could also improve the environment, for the living quality for the people in that city.
That's pretty good. Okay, so you've kind of got at the mobility management there a little bit. Is there something in mobility management that we didn't cover in that previous discussion?
I mean, there's finer points, but I'm not sure there's any major point to be made that we didn't hit.
Okay, in terms of anything that you would be wanting to...
And so maybe one major point, but I suspect Hyder already hit this, is the ability to look around corners or look through other vehicles, using, for example, cameras mounted elsewhere other than on your vehicle so that you get a different perspective of a scene.
Go ahead and tell us that.
Okay, So one of the key advantages of a smart infrastructure connected to vehicle technologies is the ability to either look through other vehicles so that you could see what's going on the other side of a vehicle. For example, a pedestrian crossing in front of a delivery truck that you can't see through and you don't really know why they're stopped there, but if you continue on, you might actually hit that pedestrian who's continuing in front of traffic. Another mechanism that can be used here is using infrastructure cameras to look around corners in intersections where buildings might block the view from your particular standpoint. So it really gives your vehicle the ability to show you multiple perspectives without having the ability to actually look around those corners. You have infrastructure components that let you do that.
Okay, so talk a little bit about how these things come together, how Canvas integrates with these other two areas.
Okay, so let me refine that question a little bit. So by that you mean how Canvas integrates with smart infrastructure and mobility management?
Mm-hmm. Like what role does it play?
Okay. Let me think
Or
about
vice versa.
Yeah. Okay, so the integration of Mobility Studio with the components of smart infrastructure and Canvas include connectivity of the sensors. It includes the ability for one to share information from the other. For example, that question of being able to share cameras among all of these components is an important aspect, but also the ability, for example, if one vehicle has a set of radars on it and other vehicles lack those, for example, for economic reasons, one might be able to share that intelligence among multiple vehicles of different economic capabilities. And so that might be one mechanism by which we can use a few high-end vehicles to improve safety on the road for all the surrounding vehicles.
Okay.
Does that sound okay? I just made that up on the spot. So.
Well, Heiger was telling me yesterday about Mo was telling me about one of the car companies having the cruise control thing that basically your car would follow the other car.
Yeah, adaptive cruise control.
Which I have that up to a point, but that if it loses, that it would follow the other car if it loses sight of the road. I'm thinking, but what if the other car's going off the road?
Well, it probably doesn't follow it out of the lane, I would hope.
Well, if it's following it because it can't see the lane, and it's following the car in front of it, you know, what's to stop it from going over the side of the cliff?
Yeah, you're asking a question on interdependence of vehicles and how much do they trust each other and how much can they verify that they actually know more than your vehicle does.
Yes,
That's a complicated question, but I mean, from the perspective of an OEM, they might want to be able to market their high-end vehicles as being not just good for the driver of the vehicle, but as a societal good. Because one of the challenges you have when you market a high-end vehicle is, are you basically saying there's two different classes of people, one class that deserves more safety and one class that deserves less safety, or do you say, well, the people who are paying for more safety are actually sharing that among all the people around them. So there's actually a societal benefit, which is a marketing, right? I mean, if you want to sell something to someone who has money to burn and you're going to sell them, it does great for you, but if you also sell them and it also does great for society, then it's worth a little more. But I don't think we need to say that on tape to them. They can figure that out.
We won't go with, we won't go okay, so this is a question I've been asking each of them, but each of you guys, but can you talk a little bit about what puts MSU in a particularly unique position to be doing this work?
So let me first answer that with respect to Mobility Studio as a whole. And then do you want me to go into the specific technologies which I suspect Heider already went into on the vehicle?
Even so. Yeah.
Okay, and if it's redundant, we'll just edit it. Okay, so from the high level, Mobility Studio provides some interesting societal benefits in terms of, for example, our campus being built out as a testing ground for particularly the aspect of very intense and high density pedestrian and cyclist traffic with lower density vehicle traffic. And so we're going to see in the state a proving grounds which is really aimed at heterogeneous vehicles and infrastructure. Our campus is going to become a satellite to test this dense pedestrian mobility aspect, which is really more relevant to an urban environment. And so if we imagine the particular advantages MSU provides for that, obviously MSU is a very large college campus. It's also a very diverse college campus. in terms of all the different mechanisms of mobility. It's also a very widespread campus with components across a pretty large land area. And so it really gives an opportunity for us to build out the infrastructure and acquire a lot of data and use that data to study these various aspects of a pedestrian-intense environment. Having these class times and things like that we actually have some scheduling control over also provides us with an opportunity to develop means to optimize around this and develop the software that does that optimization. So in fact, in our civil environmental engineering department, we've hired a number of faculty whose expertise is in either traffic safety, traffic optimization, or placement of infrastructure components within traffic to enhance mobility. And so one of the competitive advantages Michigan State University brings to this is the ability to direct some of our resources in this area, both on a campus testing level as well as at the level of research that we can use with the data acquired from all of the smart infrastructure we're placing on campus.
That was very good. That was a lot of information, but you said it really fast. Are we okay to talk about testbed in this video?
We're not a test bed yet, and so does test bed alarm people that they see test and they say, wait a minute, are we in a test tube? I don't know, that's a good question. It's a good question.
Yeah.
We might want to edit the word test out of it and just say,
Okay,
I don't know if we can do that.
So can you say that
I can say it a different way.
You can say it a different way. We could maybe pull that
and splice those together where you need to.
Yeah. So,
all right, let me try
basically that MSU provides instead of test bed, what did we say? And we'll put together the one pager that.
Well, I think I can say it in a way that rather than testing, I'll suggest that we're putting smart infrastructure in place that allows us to measure and observe, and from that data we can study simulations on how to optimize. So I think that's a way to put it, which certainly won't inflict any concern on anyone.
Yes.
Okay. So one of the advantages that we have at Michigan State University is a pedestrian-intense environment with a lighter vehicle traffic and a significant cyclist component as well. One of the advantages we can use is to develop smart infrastructure on campus that allows us to measure the traffic patterns and the mobility patterns in that environment and use that to study and optimize and develop software to optimize mobility in that environment to determine, for example, where students go, where faculty go, where vehicles go, and really understand how we might optimize the system for highest efficiency and especially for highest safety.
Okay, is that one of those, I think? Okay.
Do you want me to say something about specific technology at MSU that impact this?
Yes.
Okay.
So,
sorry, I'm asking questions for you.
No, but specific technology in couched in the words of, MSU being, uniquely qualified or highly qualified to be engaged in this work because we have this long-term research focus in this area, and that's, et cetera.
Okay. So one of the chief advantages MSU has in the mobility sphere is a long and deep experience in a number of technology areas. One of those areas is biometrics, including, for example, fingerprint, facial recognition, iris recognition, and so on. And so those are certainly key components of mobility in terms of recognizing who an authorized user of a particular vehicle or technology might be, and also what their limitations are, so that, for example, you could limit your teenage son to a geofenced area between, for example, school and the place where he works, so that he can't just go off and play with his friends. He's limited in terms of where he can go by this decision by the owner of the vehicle, the parent in this case. Other technology advantages we have include, for example, antennas and electromagnetics, and so that's around radar. For example, multispectral measurement using radar, vision, infrared, and so on to recognize a scene, recognize obstacles, determine the materials that those obstacles are made of, and try to determine a course of action subsequently. And so we have one of the strongest groups in the country in terms of machine vision, and especially multispectral machine vision, and that includes the ability to determine people with disguises on, so you can actually see through the disguises using multispectral technology. So that may also turn out to be useful in terms of use control of vehicles, as well as management of personnel access to various areas and so forth in a mobility management scenario. In addition to that, we have a very strong antenna team on campus, and so that antenna team is able to do, for example, phased array antennas, so that you could have an antenna that sweeps a wide area without any moving parts. You can have highly focused antennas. You can make lenses out of these arrays, so you can have highly focused antennas so that you can look longer distance and shorter distance. So the economic impact on this is to make the vehicle cheaper by requiring fewer of these antennas, since you can use one antenna with a wider degree of agility to view an entire scene. In addition to that, we also have a strong deep learning and pattern recognition group. And so this is one of the techniques by which the artificial intelligence design or decision-making process of a vehicle is realized. And so this is really I think, going to be the leading edge of a lot of technology that comes out of this mobility ecosystem. Will include the ability to fuse data from multiple streams, be that vision, be that LiDAR, be that radar, and maybe high frequency radar as well, which is one of our particular expertises here at MSU, and using all of those modalities to determine what's going on in a scene rather than relying on one only, which might be, for example, not as effective with certain environmental conditions such as precipitation.
That's great. Go back to the piece that you talked about, the iris recognition and facial recognition bit, and the example that you gave of a teenager, having their activity in the vehicle described. Just restate it again, just a little bit shorter if we could, because that's a completely different area that we hadn't talked about before.
Okay.
Interesting.
We have talked about that before.
Well, we talked generally, and just that particular instance didn't come up in our discussions with me.
Okay.
I mean, we talked about, like, if a person was too drunk to take over, that sort of thing. But
this is basically the same thing, but
yeah,
instead of being
application.
drunk by alcohol, it's being drunk by hormones, but it's the similar result.
It's like, let me get my checkbook out. I have a 19-year-old that I need to,
Right. Okay, so let me see if I can state that more succinctly. And maybe one other thing I should put into that framework, maybe I'll just start with machine vision and then narrow that down to how we might use that to what I call use control, who has authorization and how they might use it. But I'd like to include in there the ability to recognize pedestrians, because that is a unique capability that we have, as well as to recognize eye movement and eye focus, because one of the technologies we've developed for people who study marketing, they study people who go in and shop and store shelves and how long their eye lingers in various places. And so we've developed technologies to actually see what their eye, where their eyes are going, so we know which labels attract attention and how long and which things they pick up. And so using that technology, we can also tell, for example, did a driver see the deer off to the side? Did they notice the toddler playing with the ball over here? Did they have their eyes scanned the scene, or are their eyes just locked in on something because they're talking on the phone and not paying attention? So let me try to see if I can hit all of that in one funnel. Okay. One of the key technologies that we've developed at MSU includes biometrics, and in particular facial recognition and iris recognition, and this is using multispectral technology, so one can actually see through disguises as well. One of the uses of this sort of technology in vehicles might be to recognize an authorized driver, and even, for example, recognize your teenage son as the driver and set limits on the vehicle in terms of where it may go, geofencing it between school and work. For example, setting limits on the upper speeds and the upper accelerations it may achieve. And so there are many things that one might set according to that facial recognition. In addition, that visual recognition and machine vision software has also been used to be able to recognize pedestrians and cyclists. Using multispectral vision, our technology can also see pedestrians and cyclists even when they go into areas with high contrast, such as going from a sunny backlit scene to a shaded tree. And many visual technologies will actually lose track of that that person, but a multispectral technology can continue to track them in that scene. In addition, the eye tracking technology that we've developed can also detect what a driver has seen if they've looked over to the side where a deer might be in the bushes or a toddler playing with a ball on the side of the road might be standing, and if they've actually noticed that, or if they're just so intent on their phone call and their eyes staring straight ahead that they haven't noticed some key potential dangers that the vehicle can then mitigate for.
Okay, does that work
Good.
for you?
Yeah.
All right. Is there something that we haven't talked about yet that you feel should be part of this discussion?
So I alluded to using the campus as a place in which we can study and acquire data. I did not allude to Willow Run, and maybe in this framework we don't want to.
Okay, well, we can go ahead and talk about it a little bit,
Okay.
just so that if we have some other use for this information, we might
Mhm.
already have it in the can and
Mhm.
just say, hey, we got some
So
of that
maybe
video.
what I can do is maybe I can describe the American Center for Mobility, which is the umbrella organization above Willow Run, and then what will Willow Run be in a nutshell, and then what our engagement with Willow Run. But that's the dicey part, because our engagement with Willow Run is somewhat speculative at this point.
Well,
but I
okay, so
can-
we won't use it in those,
Just
But-
use the
but-
qualifier, we
but-
hope to,
you know,
you know.
yeah, but that's.
Well, I hope to do a lot more than that, but I don't know if I'd want to say that on camera.
This is- we went to rule the world.
Yeah.
Oh, wait, did I say
Well,
that?
okay, so you just got to my punchline.
Oh, wait, was that tape rolling?
Yeah.
Um, Yeah, but let's go ahead and talk about it a little bit, because even if we're not using it here,
Mhm.
there may be a place down the
Okay.
road where it'd be nice to have it, and you can say, hey, remember
Mhm.
that thing we talked about a couple months ago? Let's pick it
Mhm.
up and use it here.
Mhm. Okay.
Okay.
Okay, let's see. So MSU is playing a role in working with the American Center for Mobility, which is putting together a proving ground outside of Detroit at the old Willow Run facility. This proving ground has been designated as a Department of Transportation test facility, and so once it's built up, they'll be adding, for example, many roadways and intersections, smart infrastructure, and so on to this site. This will have the capability to test heterogeneous vehicles, smart infrastructure, and mobility management software all on one single site. And so the hope is that MSU will engage this site both as a satellite site for the pedestrian intent studies, as well as being able to test our vehicle technologies there among the other testing going on there. And so we think that this will be a key national asset in terms of setting standards. We expect that the standards agencies such as SAE, the Society for Automotive Engineering, as well as the IEEE, the Institute for Electrical and Electronics Engineers, both of which manage vehicle standards of various sorts, will come into play at this site and curate the standards which are developed there by a combination of universities, industry, and the government.
Okay, that's actually pretty good. So something that came across my desk as a Google alert a couple weeks ago was that MSU, U of M, is it Carnegie Mellon, and a couple of universities are part of something that includes the Pennsylvania Turnpike Authority, and it sounded like it was somehow connected with autonomous vehicle research.
Okay, I'm not familiar with that one, although you may be just talking about they're doing some testing in Pennsylvania of Uber vehicles, and they're going to be geofenced to a few places in Pittsburgh as well as a few freeways. So that might be.
Or something that engages MSU and U of M and Carnegie Mellon?
So there is there's a automation and manufacturing national manufacturing innovation initiative that we just won a few weeks ago. And that's around using, for example, robotics in manufacturing, but I don't think that's
Okay.
directly relevant to
Okay.
this.
I couldn't tell. I think the press release that came out was like one of those ones the PR Newswire does that
Mhm, mhm.
like tells you nothing.
Right.
So I
Well,
couldn't
well,
quite
in
figure
fact,
out what it had to do
it turns
with
out that OEMs and even tier ones are already so automated that they're not really expected to play a big role in that. They're really aiming that at smaller manufacturers who can't afford to develop their own automation technologies. But OEMs are way ahead of the curve on that, so I don't think that they're really the prime target for that project.
Okay. So is there anything else that we haven't kid on here that you think is something we want to make sure that we cover in this short video?
I could say a little bit about lightweighting vehicles, but because that's so speculative, I'm not sure that's, if you're going to have to cut this down to below 10 minutes, which I'm sure you're going to have to do that. I don't think that's going to make the cut.
Tell you what, let's talk about it a little bit and know that we're not going to probably use it here.
Okay.
But again, it's one of those, I've got you here for
Sure.
3 minutes, let's talk.
Because I have time on.
It's because you have a tie on, you're looking good. You look like you know what you're talking about.
Right,
Yeah.
okay. So one of the interesting developments that we're studying for a campus is the potential for a park once model where people arrive at campus, park their vehicle once, and then use, for example, lightweight vehicles which are far safer, such as autonomous golf carts, to move around on campus from office to office and from sector of campus to sector of campus, in addition to maybe some primary bus lines or van lines that move people around between major arteries. Using these lightweight vehicles to get out to the area where you may have parked is one thing that we're contemplating on campus as a means to improve mobility and reduce the footprint of vehicle activity in the center of campus, where the pedestrian intensity is such that poses safety and also efficiency issues.